Hey guys, welcome to Unit 3, Lesson 1, Part 2. And we are going to be just continuing on with the things that we talked about in the first part. So the first thing I want you to do is kind of recall your knowledge of the reference angle. So remember that it's always positive and acute, and that also all angles in quadrant 1 are equal to the reference angle. So I'm going to write that down and then we'll kind of continue on. Okay, so we are going to be doing the exact same thing that we did last unit, except we're going to be applying it to radian measure. So like for instance, this one, I'm just determining the reference angle. So we're going to get to incorporating the trig function, but right now I'm just focusing on this. So if I have a 150-degree angle right here, what would that reference angle be right here? So you're like, oh my goodness, that's easy peasy, that's 30 degrees. Okay, well, we're going to apply that same concept. Instead of now saying 150, we're going to say this. So if you'll notice, everything here is 4, 6, 3. So it's just shouting out to me that it is on the unit circle. So let's practice your unit circle and finding these angles. Another way to do this is if you're not sure what this is, what kind of reference angle it is, 4, if it is over 4, most likely, not always, but most likely it's going to be some sort of a 45-degree angle. If it's over 6, that is some sort of a 30-degree angle. And if it's over 3, that's some sort of a 60-degree angle. Also, you can always transfer. Um, so like in this case, we're going to multiply by 180 over pi and cancel out. And then we would take 7 times 180 divided by 4 and get 315. So you know that this now, I mean, you can picture that, what that looks like. And that's a 45-degree angle reference. So see if you can kind of play around with these two and see what you get. And one more thing I forgot to say, we're not going to give it in like 30 degrees. We're going to say pi over 6. We're not going to give it in 45 degrees. We're going to say pi over 4. So we're really kind of forcing our brains into that radian mode. Okay, I'll turn you loose now. Okay, so let's go through this. So this one ended up being pi over 4. This one pi over 6. This one pi over 3. This one was in degree mode, so I'm going to keep it in degrees. So again, just stay consistent. This one had a rotation in it, so it's really too big, but I knew that it was still over 3, so it's a 60-degree angle, so I said pi over 3. This one is completely different. So what I did is I started here, and I saw that this gave me a yucky decimal angle of like about that. And so I knew that was kind of like a dead end. So I restarted and kind of rethought this. So I knew that 2 pi over, like if I thought about it in terms of over 7, would be 14 pi over 7. And so I went there because I knew that this was in the fourth quadrant. So it was somewhere between 270 and 360. So I wanted to take this this fraction here and find the difference between my angle and that fraction. So that ended up being 3 pi over 7 for my reference angle. So some of these are kind of puzzles, and I just wanted to point that out. Okay, so this next one, we are going to do solely like calculator things here and just kind of mess around with what we have. So it says evaluate each trigonometric expression. If necessary, to the nearest hundred. Use your calculator and make sure it's in radian mode. Okay, so all of you guys have different calculators. If you have a TI calculator, look for the mode setting, and it's usually at the very top, and you're going to click it from degree to radian. If you have another calculator, you might just, I mean, it should be pretty similar. It should be in that mode. If not, I would Google it, and I can also help you as well. So let's start with number 1. So we're going to type in the sine of 2.46, and you're literally just typing it in your calculator, and it should be about 0.63. Okay, so for this next one, a couple things that are going on. First of all, this is too big, and so I need to take out a rotation. And then also, this is some type of 45-degree angle, I think. So I think what I want to do is take out the rotation, kind of see where it is. So 2 pi is the same thing as what over 4? So that's 8 pi over 4. So let's kind of do that first. So I'm going to get 2 pi over 4, or pi over 2. Oh, pi over 2. So 2 is that quadrantal angle. So it's going to be right here. Okay, so I'm going to ask myself what the tangent of pi over 2 is. So let's see, this is 0, 1. Tangent is 1 over 0. 1 over 0 is no way, so it's going to be undefined. Okay, try 3, 4, and 5. Okay, so let's talk about each one of these. So this one, I went ahead and added the 8 pi over 4. And so this really, I knew it was over 4, so I knew it was going to be cosine of 45 degrees, the square root of 2 over 2. But I wanted to see like where it was on the coordinate plane to figure out positive or negative. So if you'll see these like right here, this is my thought process. I don't know if this helps or not, but like every 45-degree angle is like 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So that's kind of what goes through my head when I do this. So I knew that it was in that third quadrant, and I knew that cosine was negative in that third quadrant. So that's how I got that. Number 4, obviously, I couldn't, I mean, it was just a yucky number, so I just typed this in my calculator. So again, it doesn't matter how you type it in your calculator. You could do this, or remember, I do cosine of 1.56, and then I do that flipper button to find the reciprocal of that. Either way, it's fine, but you should end up with this. So again, that's just about knowing your calculator. Okay, so on number 5, the first thing that was jumping out at me is this 9. So I knew it wasn't a special angle. So I used, this is actually a calculator problem. I used my calculator for that because it wasn't a 3, 4, or 6. And so and I just typed it in again, like 1 over the tangent of this, or I definitely did tangent of this and then use that flipper button to find the reciprocal. So either way, it's just